Right, the first three terms of a geometric sequence are 3k plus 4, 12 minus 3k, k plus 16. Show that k satisfies the equation blah blah blah. Well, what you've got to do, you've got to use the fact that if three numbers, a, b and c, are in geometric progression, then it means that a times c is equal to b squared. So in this case, we're going to get that 3k plus 4 times k plus 16 is equal to 12 minus 3k, all squared, like that. Therefore, multiplying this out, we get 3k squared plus 48k plus 4k plus 64 is equal to 144 minus 2 times 12 times 3, which is 72k plus 9k squared. Now, if we collect all the terms on one side, we should get the what they want, which is this. So we get minus 6k squared plus 48k plus 72, 120. Just a moment. We're not going to get 120. We should have 124. Oh, there's a 4 here, isn't there? Yes, sorry, 124. Okay, yes, it's 48. 52 plus 72 is 124. Minus 80 equals 0. So multiplying through by, well, I'll just times through by minus 1 first of all. 6k squared minus 124k plus 80 equals 0. So therefore, finally, we have 3k squared minus 62k plus 40 equals 0, which is what they've got here. So as required. So that's part A. For part B, it says, given the sequence converges, find the value of k, giving a reason for your answer. Okay, well, we've got to solve the equation. So we go k is equal to 62 plus or minus the square root of 62 squared minus 4 times 3 times 40, all divided by 2 times 3, which is 6. I know it should be strictly minus 62 squared, but it's not going to make any difference because you're squaring it. Anyway, so you get 62 plus or minus, we've got to work this out, 62 squared minus 12 times 40, 3364, square root of that, which is 58, all over 6, and that gives us our two answers. So it's 62 plus 58, which is 120 divided by 6, which is 20, and 4 over 6, which is 2/3. So those are our two answers. So k is either 20 or 2/3. Now, it says, given the sequence converges. Now, I must admit that I did this question earlier, and I did it wrong because I was thinking that this was the value of the common ratio, but it's actually, it's not. It's the value of k, where you've got to find the first three terms now by replacing k by 20 and then replacing k by 2/3 and seeing what the sequence looks like. So anyway, so let's start with k equals 20. If k is 20, right, what we get is that the first three terms will be 3 times 20. bring this up. 3 times 20 plus 4. 12 minus 3 times 20, and 20 plus 16. Right, so that's going to be 64. This will be minus 48. And this is going to be 36. Now, these are the first 3 terms. And that's it. These are the first 3 terms. Now, it turns out, you see, that if you want to work out the common ratio from these 3 terms, the common ratio is going to be this term divided by that one, or this one divided by that one. So it's going to be minus 48 over 64, which is actually minus 3/4. That's the common ratio. 36 over minus 48 it gives you the same answer, of course. In the other case, if k is equal to 2/3, then what we get is the 3 terms are going to be 3 times 2/3 plus 4, which is 6. Then we're going to get 12 take away 3 times 2/3, which is 10. And we're going to get 2/3 plus 16, which is 16 and 2/3. Now, if you look at the common ratio this time, the common ratio, okay, these are our terms. They're 6, 10, and 16 and 2/3. Again, it doesn't matter whether you divide this one by this one or this one by this one, but either way, if the common ratio is going to be 10 over 6, which is 1 and 2/3. Well, the point here, you see, is in this case, the common ratio is between minus and plus 1. So for a sequence to converge, the common ratio must be between minus 1 and plus 1. So it turns out that this indeed is the correct answer. So k equals 20. As I say, this caught me out earlier because I just took it for granted that that was the common ratio, but it's not. Anyway, so now we've got to find the sum to infinity. This is part 1 of part B. Part 2, well, the sum to infinity then, the formula for this is a over 1 minus r, which is equal to, the first term we've established was 64, and the common ratio we've figured out to be minus 3/4, so we get this rather awkward expression. Anyway, so it's going to be 64 divided by, open brackets, 1 and 3/4. That's it. Which is, oh dear, 30, hang on, I don't think I want to write it as a decimal. 64 over 7 over 4, which is going to be 256 divided by 7, because it's 4 times 64 divided by 7. Yeah, that's right. Okay, so that's how you do this this question. A bit of, well, it's question 9. They're getting slightly harder, and that one, as I say, that one threw me first of all. Thank you.